Thanks for having me, folks. My name is Sohan Maheshwar. I work at a startup called Unauthorized. I'm based right here in Amsterdam, so always nice to talk to a local audience. I'm going to be talking about two things. Mostly authorization and how this is being solved at a very large scale, specifically at Google, and also now in many other companies, and a little bit about AI, because we can't go too long without talking about AI, or our industry will implode, apparently. I don't know. In any case, once we have the screen up and running, oh, I think this is not connected. No, this should be good to go. Yeah, there we go. All right. So I'm going to start with a question to the audience, but I must warn you, if you know the answer to this, you might reveal your age. So be careful if you shout out the answer. But does anyone remember this website from back in the day? Maybe early 2010s? Anyone remembers it? No one? Yeah, OK. Yeah, yeah. A few of you all might remember this. Anyone wants to shout out what it is? Anyone? Yeah, no? OK. This is Google Circles, or it was also called Google Plus officially. And this was Google's attempt at a social network. And it was all the rage for precisely like a month, and then no one used it. But the idea basically was you could have circles of people. So you could have like university friends and like childhood friends and coworkers, and you could share things only within a circle. And while the social media, while the social network itself didn't do very well, the story goes that Google re-architected how they were doing permissions and authorizations internally. And they moved it to a very centralized way of authorization. And you might have actually noticed this if you've ever sent a Google Docs link in a Gmail. Right? So over here is Gmail. You've sent a Google Docs link, and there's a pop-up that says, hey, does this person have access to this particular document? And if you think about this, this actually is kind of like magic, because Gmail and Google Docs are two completely separate apps. But yet, there is a permission check that's happening when an email is being sent. So how this happens is basically what I'm here to talk to you about today. Essentially, we know how this works because in 2019, Google released this white paper called Google Zanzibar. And Zanzibar is also, confusingly, the name of Google's internal authorization system. Now, to give you a bit of a primer on authorization, not to be confused with authentication. Authentication is identity, who you are. So if you've used Okta or Microsoft LDAP, Active Directory, whatever, that is authentication. What permissions you have after that is authorization, so what you can access to. And in the past, people have done things like role-based access control. You might have this at work, where you are tagged a DevOps engineer, so you can check in code, or you have access to a Kubernetes cluster. If you're tagged to a role that says sales, you have access to things like a quarterly report. And things changed a little bit because role-based access control didn't really scale to something called attribute-based access control, where everything is an attribute. So for instance, my name, my email ID, my location, all of this would be an attribute. And at the time of the decision being made, you would check all these attributes and say yes or no. Now, the thing is, attribute-based access control also has some problems at scale. And Google, being at Google scale, wanted to do things a little differently. So they popularized this idea of something called relationship-based access control. And the Zanzibar white paper actually tells you exactly how it's done. So one, if you have the time after this conference, do read the white paper if you're interested in things like distributed systems. It's written in very non-academic language, so it makes for good bedtime reading. And they actually talk about their entire internal authorization system, about how it is consistent and at a global scale, which, as you might know, is kind of a hard problem to solve. And in 2019, they actually said it could do more than 10 million queries per second, which is a staggeringly high number, and I'm sure that number has increased. And they also talk about this concept of reback, or relationship-based access control. So what is reback? Essentially, anything is determined in the form of a relationship. So say you have Does this work? Yeah. So say you have a document, and that document exists in a folder. There is a relationship between the document and the folder. Say you have users. There is a relationship between the users and the folder, and hence there's a relationship between the user and the document. Now, what can you have relationships against? Well, according to the Google Zanzibar white paper, it has to be a user ID. So if you have a Google ID, you're in there, I'm sure, and any object. An object could be a folder, it could be a document, a YouTube video, a photo, anything. And these relationships, again, could be anything. For instance, you could be a member of a Google group. You could be an editor or a writer of a document. You could be an uploader of a video. So you have a user, you have a thing or an object, and the relationship between the two. And now you need a way to represent this in a way computers understand. So the Zanzibar paper talks about this thing called a relation tuple. Now this is just a way to represent the same data. And the way to read this is start at the hashtag and start on the right. If this is confusing, contact Google. I didn't count for this. But basically, this says user number 3 is an owner of document 123. And that's how you would write this into their authorization system. This form of tuples is very flexible because objects can also relate to other objects. Objects could also relate to other objects' relations. So for instance, you can say security group is now member of group engineering. And think of reorgs you've had internally at your company where suddenly security is part of the platform team. All it would entail to make that change was just to rewrite this tuple and run it in the system, as opposed to creating new roles or new attributes for everyone. So that gave them the flexibility. But honestly, what are we doing with all this information? How does this relate to a permission check or authorization? Well, the idea is once you build these relationships, you can actually build a graph. And in computer science theory, you know that parsing a graph makes things faster and easier. So you can build a directed acyclic graph. To take the example of Google Docs, you have a document. You have 2 readers, Fred and Kim, and you have a writer named Jill. You will also notice a dotted arrow between reader and writer to imply that anyone who is a writer can also read the document. And this model gave a company like Google flexibility because what if you added, you had a new requirement for authorization. You're like, hey, I also want to add an organization into this mix. It was all about just adding a new relation tuple, which added something to the graph. So in this case, you would say org named Acme has an admin. All admins are writers, and we know that all writers are readers. So hence, any new admin can also read a document. So if there had to be a permission check for something like, hey, can Jill read some document? All you have to do is see if there's a unidirectional way to get from some document to Jill. And in this case, there is. You can go from some document to reader, reader to writer, and writer to Jill. So at any point of time, if you have accessed a Google Doc, this is probably what's happening behind the scenes to check if you have permissions to access that doc or not. The question I get asked often is, surely this doesn't scale to the level of Google, right? Like, how does this work? And honestly, it was built specifically for that planet-level scale. How they do that is probably another talk in itself, but I'll give you the TLDR. Aggressive caching and aggressively breaking things into sub-problems. So, for instance, when this check happens, right? The check is, can Jill read this document? You will actually notice it's a union of 3 checks here. The first, it goes to see if Jill is a direct reader of a document. Nope, that's Fred and Kim. And then, is Jill a writer of this document? Yes. And all writers are readers? Yes. The good thing is, since this check is made, the reader check, that result is stored in a cache. So say, after that, if a query comes in saying, can Kim read this document, that is already stored in a cache that can be accessed faster. So this check is not being made again unless you specify the system to make that check again. So the Zanzibar white paper actually details how all of these things are aggressively broken down into these sub-problems. And each of these problems are cached very aggressively. The interesting thing is there's also a subsection about what to do in case of something called a cache hotspot, where, say, a document or a video goes viral, and suddenly lots of people are accessing it. So it sort of batches reads to the data store as well. So say 100 people access it at the same time. It waits. It makes 99 people wait. It makes 1 people do the entire thing in the graph, gets that result back, and the other 99 access it from the cache. So there are very cool ways that it actually looks at these different hotspots to make it low latency so that we don't have latency while accessing this. Now, this made waves in the whole security authorization IAM space when it came out in 2019. Big companies such as Airbnb and Carta actually built teams, centralized platform teams, to re-architect their authorization based on this. At the same time, there was open source versions of the Zanzibar white paper as well. And for those of you all familiar, there are lots of tools we use nowadays that actually originated in a Google white paper, the most famous being Kubernetes. So the idea is really to de-Googlify, if that's a word, a piece of Google software so that the rest of us that don't work in Google can actually use it. The 4 popular ones that exist now and that are being used are SpiceDB, Ori, OpenFGA, and Permify. So they were all open source versions of the Zanzibar white paper. I will talk a little bit about authorization and SpiceDB because that's the one I work on today. Just to give you some context about what SpiceDB is, again, open source version of the Google Zanzibar paper that's tried to stay as close to the Zanzibar implementation. Started off as a project 5 years ago, but now has contributions from like Reddit and GitHub and so on. But I think the only metric that matters to us as developers is GitHub stars. So yeah, there are 5,800 GitHub stars. Can always use more, I presume. Just to give you a bit of context about what SpiceDB is, essentially the name suggests it's a database, but it is a database, but it's not a general purpose database. So you can't really use it as an RDBMS to store general data. It's essentially a highly parallel graph database, purely meant for authorization queries. And usually you use it with a data store that stores relationship data. For devs and platform teams that use it, all you need to know is it's like an HTTP API or gRPC service. And the APIs do 3 things. The first one is to read and write what's called a schema. Now, the Zanzibar paper basically says you have a use case, right? It could be something like Maps or YouTube or Google Docs. You can actually say, have a schema that looks at that use case, and you model your use case on that schema. Again, going back to our classic Google Docs example, you have a definition of a user, you have a document, and you have the relationship between the user and the document. So in this case, a user can be a reader or a writer of a document. And a writer can edit a document, whereas the person who can view the document is both a reader and a writer. So you have any use case, and you model it using schema. Once you have that, you can create, read, update, and delete relationships. Again, we do that using the relationship tuples that I spoke about. Going back to a classic example of a Google Docs-style app, you have a document, a reader, and a writer. And you would write a relationship by saying something like, some document write user as Jill. And if you want to change this, all you have to do is change the tuple and write it to your system. So you have a schema, you have relationships. Essentially, you can now make permission checks from your app. And that's, again, fairly straightforward to use. Again, going back to our example, there is a check permission API where you can check if, say, Fred has reader permissions on the document. You can also do a couple of reverse lookups. For instance, you can look up all subjects a given type has access to. Like, give me all the people who can read some document, and it would give you all these names. And you can also do a reverse lookup where you're like, give me all documents that Kim can read. So it looks at the graph, but going the other way around. And remember this because we're going to use this in our demo, where we take AI agents and we use these check permissions to see if the AI agent can access a piece of data or not. I did mention that the Zanzibar system made waves in the IAM space because it really worked well when you have a lot of data, when you need low latency and high throughput, and when you know the relationships between these data, which could change often. And turns out, when you're working with a lot of documents and AI, this actually is a system that is well suited for it. So let's talk a little bit about AI. Essentially, I like to think of 2024 as a year that we all tried proof of concepts and experiments with AI in production. But in 2025, we're thinking about the day two ops of AI. How do you do all of the operationals around AI? And we have all of these things, right? We have RAG pipelines and agents and MCPs and LLMs. So really today, I'm going to be talking about two things. An AI agent that does something in the context of a RAG pipeline. Essentially, a RAG pipeline is an architectural choice. It stands for Retrieval Augmented Generation, where the idea is simple. You have a corpus of documents and data that is domain-specific, and an LLM might not necessarily know much about that domain. So instead of training a model from scratch on those documents, you augment a LLM with knowledge from those documents. So the most common example is a chatbot in an enterprise. In an enterprise, you know a lot of, or you have a lot of documents, and you're like, hey, I will use an existing LLM, and I will access these documents using this architectural approach called a RAG pipeline. Now, in this whole rush to implement AI, there's not been too much talk about the security aspects of it. And in fact, has anyone here heard of OWASP? Open Worldwide Application, security project. I think anyone who's checked in code at any point of time has heard of OWASP. So they make lists about risks for web apps and LLMs pertaining to security. And late last year, in November, they actually came up with their first top 10 for LLM apps list. And 3 of them, which is sensitive information disclosure, excessive agency, where an AI agent does things it's not supposed to, and also vector weaknesses, where I can maliciously inject code into a vector database to do things. All of these things can be addressed by proper authorization. So that's essentially what we're going to be talking about right now. To take a look at the typical architecture of a RAG pipeline, there are 2 phases. The first phase is the ingestion phase itself, where you're ingesting documents. So you have a knowledge base of documents all the way here. You can pre-process the data to break it down, to clean it up, and send that through an embedding model. Now, for those of you all who may not have context, essentially an embedding model is a way to represent words, images, and so on in numbers, because that's what a computer can understand. And you can take those embeddings and store it into a vector database. There's one key element here, which is in these embeddings, you can actually also store metadata, which is here, which says that this particular piece of information came from this particular file. And we can use that to actually determine who has access to that file, and hence improve our AI agent authorization. The second phase of a RAG pipeline is the query, retrieval, and response phase, where you have a user who uses an agent to make a query. The query also goes through the embedding model, which also goes into the vector database, which then goes into the large language model, and you get a response back. The one key thing here that's missing again is the fact that there is no security or authorization. Right? This agent is accessing things that it may not have access to, at least based on the user. So how do you add this authorization to this agentic RAG pipeline? We've fundamentally seen 2 ways that people are doing it, and 2 ways they're preventing AI agents from accessing unauthorized data. There is what's called the post-filter approach. So going back to architecture, user makes a query, goes to the embedding model, goes to the vector database, and then you can actually do a filtration with that metadata that I mentioned. So with every request that's returned, you actually use a Zanzibar-like system and do a check permission request to see if this user has access to that file that the data came from. So for everything, you're actually doing a check permission request. And if that permission request comes back positive and it's like, yes, this user can access it, you then send it across to the LLM, which gives a response back. Typically, we have seen companies do this when you have a high positive hit rate of the number of documents that you get here. So say you have 1,000 documents, and the user can access 900 of them. This is a good architectural approach because you do a check permission request for those 900 relevant documents, and then you get a response back. If it's the other way around, say you have 1 million documents and the user can access maybe just 5, this approach may be a bit inefficient, in which case the approach of doing a pre-filtration works better. So in this pre-filtration approach, again, user makes a query that goes into the embedding model. And before anything, you look up all the documents that the user has access to. So instead of querying for a specific document, you're like, give me all the documents the user has access to, which in this case could be a few. And then those documents are part of the embedded query that go into the vector database. So in the case of maybe you have, again, 1 million documents and the user can access 10, this is a far more efficient system where you get the 10 documents and then use that as part of the query to ensure that the AI agent queries only those 10 documents. So this is the demo that I will show you today. It's a simple demo in a Jupyter notebook. And in the demo, I'm going to use Pinecone, which is a vector database, but you can also use something like pgvector. I'm using OpenAI as the LLM, but again, you can swap it out for any. And again, I'm using SpiceDB as the Zanzibar-like system, but again, you can use any of the open source versions of Zanzibar. The entire demo is on GitHub if you want to check it out. It's in a self-guided way, so feel free to clone the notebook and follow along. If you want to take a photo, you can. Also, going to make a quick prayer to the demo gods, because we know conference Wi-Fi can be. All right. Hopefully, you can see my screen. Yeah. So essentially, what I'm doing is I have a version of SpiceDB up and running locally. Right? It's running locally on my system. So any call I make goes against this version of SpiceDB that's running locally. In the beginning, I've just initialized a bunch of clients, and I've created a Pinecone index already that you see here. It's called agents. You don't have to worry about that. The first thing I mentioned was the creation of a schema, which is what you see here. We're defining our use case. We have an agent, we have a document, and an agent can either read or not read a document. So when I run this, it basically writes the schema, you can see here, 259, to my SpiceDB instance. And then it's about creating relationships between the documents that you have. So I've just defined 3 documents for the sake of simplicity. A sales agent can access document 1 and 2. A HR agent can access document 3. And the relationships between them as well. I'm writing that these agents can read these documents. So this is how you would write a relationship into any Zanzibar-like system. And you can see here that the relationships are written. I'm just going to add some sort of text to the documents, just very boilerplate text, and I write this into Pinecone, which I've already done. So the data is already in my vector database. I'm just going to go to the next slide. Yeah. And now I've created 2 methods. One is to get the list of authorized documents by running a lookup resources request, which runs a reverse lookup, says these are the documents that the user can access. And I will create a query embedding using LangChain with the OpenAI LLM. So let me just run that. And now it's simple. I'm just creating a method to query this RAG pipeline with my AI agent. So I'm just going to run it. And it does a check of what documents are allowed. And if it's not authorized, it says you're not authorized to view the content of this document. If it's authorized, I just do some prompt engineering to say, look, you are an AI assistant. Just look at these documents and give me a response. So in this case, sales agent can access project doc2. So let's run that and see how it goes. Yeah. So it says, OK, good. It's about customer use cases for the sales team. It cannot access document 3. Right? And it says, OK, you're not allowed to view the content of this document. You can also generate a summary of all the documents that this user has access to. So in this case, again, doing a lookup resources request that gives me the documents I can access. And I fetch all of that content from my vector database. And then I use some prompt engineering to summarize the document. So let me run that. OK, that's run. And I'm just going to call that method. So it's saying sales agent can access document 1 and 2. And it gives me a summary of all of that. Now, in something like a RAG pipeline, these permissions can change often. Suddenly, you don't get access, or you're removed access from a document. How do you handle that? So essentially, it's about just writing a new relationship or deleting an existing relationship. So here, we're telling sales agent is being deleted from this document too. That relationship will no longer exist. And you can see back here in my SpiceDB, this new relationship has been written. So now, when I query that document again, it says, oh, wait a minute, you're not allowed to access this document, because that relationship between the document and the AI agent has been removed. Now, this, of course, is a very simple, straightforward demo, just for simplicity's sake. But I can tell you for a fact that AI companies are doing this at scale in production right now. They're using systems similar to this because enterprises need LLMs for things like RAG pipelines and agents. But they also need guardrails around what these agents can exist. And they're also seeing like second-order effects, which is effects that are not the intended effects, but something that happens later, where with a Zanzibar-like system, you can log any change to permissions and any permission check that's been made as well. So say a permission change has been made and someone makes a check, that is logged. And the cool thing is you're building efficient RAG pipelines and agents at scale, because there is a filtration that happens when you actually build it out this way. All that being said, there are still lots of unanswered questions, because this whole space is new. And there are some known unknowns, because we don't know for sure what the DevX around AI agents would be like. We don't know who is it authorizing against. Is it a user? Are you attenuating a sub-session against the user? We don't know that quite for sure. And at the same time, there's this talk about an MCP, a Model Context Protocol, for which the authorization spec itself is very nebulous. There is not much clarity against how this MCP and authorization would actually work. So as the space evolves, I think we will see some levels of standardization around it, and we'll get a better sense of how this would actually look. In any case, for next steps, I'd say do check out the Zanzibar white paper. Again, it's written in plain English, so it's good read. And this demo is there on the link that you see there. If you want to learn more about how authorization works, check out SpiceDB and so on. And I hope you learned something new today. Feel free to connect with me on LinkedIn or after the talk, and thank you.